Hello, welcome to today's daily Leetcode challenge. Today we'll be solving question 229, majority element 2. I'll be going through my thought process as I come up with a solution, then stick around for the end of the video where I compare my solution to the others. So question 229, majority element 2, given an integer array of size n, find all elements that appear more than n divided by 3 times. So it seems like we can just make a dictionary of counts, where key is the element, value is the number of occurrences, and then for each value, for each key whose value is greater than some number that we can easily calculate, we'll add that value to a return data structure, which would probably be a set that gets turned into a list. Let's see if there's a cleaner way to do this. We could have we could calculate the dictionary that holds the key value pairs, as I said before, and then we could iterate over the dictionary just once, pretty much, to get the values. But regardless, let's begin coding. I think this is definitely not a medium, but let's have counts be a default dictionary with int, which gets initialized to 0 as the beginning value. Then for n in nums, count n plus equals 1. At this point, we'll have all the counts, and if count of n is greater than len nums divided by 3, we will add to res this number, and then return a list of res. Let's see if this works. Type is not subscribable. Counts. Oops. And let's have the size. Let's call it size. Len nums. No. Threshold. Len of nums. Oops. Nums divided by 3. This. Yep. Let's keep this, again, simple. I don't understand why this is a medium. And yeah, it beats 80%, which is fine. Let's look at the best solution here compared to others. This is the threshold. This is just the nums. And then it uses the default, or a property that arrays or lists in Python have called count. It essentially is counts how many elements are in, how many elements of that number are in nums. But I don't understand why this is faster, because under the hood this would have to calculate the count for each I in n on the dot, rather than just calculating it all at once. I think that this is pretty much the same solution, just phrased a little bit differently. I don't see any reason to do it any other way, essentially. Yeah. So I absolutely use this. Quick and easy and very intuitive. Cool. Thank you. Bye.